So we have another AP Calculus particle motion question. This one has to do with a trig function, and we're going to have to differentiate a couple times, so I thought this was an interesting problem. My intention in this video is to go over part A and part B. In a separate video, I'll go over part C and D because I think it's really time consuming. So we have an ant that moves along the x-axis so that time t, its position is given by x of t, its position function, is equal to 2 cosine pi halves t squared. The reason you see I have all this stuff highlighted is because this has some significance to me. First thing it says, find the expression for the velocity of the ant at any given time t. Well, I want to write this as if I was going to write it to my AP reader. So the first thing I'm going to tell my AP reader is that I'm aware that the first derivative of position is equal to velocity. And then I'm going to start taking this derivative. Remember, this 2 up here is a constant multiple, so I'm just going to leave it out front. And then I'm going to start to look at cosine, and if you look at cosine carefully, it's cosine of an inner function. So the first derivative of cosine is negative sine of that inner piece. So that inner piece just stays the same if you remember. So pi halves t squared. And then, because we are using the chain rule, we need to take d dx, or the derivative of that inner piece, right? This is chain rule. And the first derivative of that inner piece happens to be pi t, doesn't it? So here's my derivative here. I've got to clean this up a little bit for my reader, and I'm just going to state again for my reader that v of t, velocity at given time, and then this is what I'm going to do here. I'm going to gather these pieces. This is a negative 1 right here, so 2 times negative 1 is negative 2. Then I'm going to multiply that by this piece over here, this pi t. And if you're wondering, if you're thinking, man, do I have to do that? No. But I think the cleaner you make it for your reader, the easier it is for them to give you all your points. So sine of pi halves t squared is my first derivative, I think. Is that what I want to use as my first derivative? It is when I want to use as my first derivative. So that was the question. So I'm going to put a little check mark that I did that. As I do that, this is you holding your reader's hand because you want to get all your points here. So what you want to do is just put a little box around that, and this box for me is kind of holding their hand saying, look, you asked me for this velocity function, and here it is. And this other part is just adds a little bit of significance as they're reading to be comfortable with the fact that you're a good mathematician. The second thing they wanted to ask us to do was find an expression for the acceleration at any given time. So what I'm going to do is this. This one is a little bit more difficult, but this is how I'm going to start working this out. First off, I'm going to tell my AP reader that I know what I'm talking about. I'm going to tell them that I know that the second derivative of position is the same as the first derivative of velocity, which is acceleration. So I'm just laying this down for them, so as they read, they're like, okay, this person really knows what he or she is talking about. So now I'm going to start to look at this. And the way I look at this is this. I look at this, I think this is a product rule problem with a little bit of chain rule in it. But so this, I have negative 2 pi t. And what I'm saying is I think that's the first function here. I think it's this function times this function in orange. So I'm going to start gathering my pieces for the product rule. So I'm going to say f of t is equal to negative 2 pi t. Here's where a lot of people make a mistake. You have to remember that this function has a coefficient of negative 2 pi because pi is a number, right? So people get kind of flipped out and they start acting as if this is a variable, and they start doing really weird stuff with it. This is just a number. So what's the derivative of this? It's just the coefficient. So f prime at t is just equal to negative 2 pi, isn't it? So we'll leave that like that. Now I'm going to gather my g of x piece, a g of t piece. So here's my g of t piece, and that is sine of pi halves t squared. So when I start to take this derivative, it's a little bit more, had to be a little bit more thoughtful. I'm going to get g prime at t, and we know that the first derivative of sine is cosine, but this is chain rule because we have an f of x inside of here, don't we? So I'm taking a derivative of sine of f of x, not sine of x. So the outer derivative is cosine times the inner stuff, of the inner stuff, right? Times the derivative of the inner stuff, if you will. And the derivative of this inner piece right here is pi t, isn't it? So pi t. I'm going to go ahead and move this pi t to the front if you don't mind. So I'm going to put pi t right there. So here are my pieces. Now I'm going to start to put my, holy macaroni. I'm going to, sorry, I'm going to start to put my product rule together. And the product rule says we take f of x, which in this case f of t, which is negative 2 pi t, times the derivative of the other function, which is pi t cosine pi halves t squared, doesn't it? Plus, and then we want g of t, which is sine of pi halves t squared, times the derivative of the first function, which is, so times negative 2 pi. If you don't mind, what I'd like to do is put this negative 2 pi out in front. So I'm going to take this and just use the commutative property of multiplication and put this here. So this is what I'm going to do here. We're actually pretty much done with this. This is a of t, and your reader may accept this, but just in case, there are things that we can let's clean this up a little bit. A of t is equal to negative 2 pi squared t squared. Pi times pi is pi squared, t times t is t squared, cosine pi halves t squared. And then look, this negative here is going to replace this, so negative 2 pi sine of pi halves t squared. Right? These problems are meant to be this way. They're really meticulous work, and you just have to take your time. Everything is fine. Take your time and figure your way through this. But hopefully you can see that we have a factor of 2 pi on both of these, actually negative 2 pi on both of these. And I'd like to factor that out. So I'm going to go ahead and factor out negative 2 pi. I'm going to do this again. This is my final product, I think. A of t, the acceleration function, is negative 2 pi times pi t cosine pi halves t squared. Remember, I'm factoring this out, so I want this to be this has to be a negative, so a negative times a positive, right? I'm factoring out this negative 2 pi here, so it's right there. So sine pi halves t squared. And remember, this whole thing has to be like this, so I have to capture this whole thing. Wow. So that's a ton of calculus, and I know that it is. My great advice for you, and I think it is really good advice for you, is that you need to do a lot of these problems. And believe it or not, the more of them that you do and the more of them that you look at, the better you get at it. And pretty soon they all look alike, and you're like, oh, it's one of those. And you'll get really good at it. Try not to give up on yourself. It can be very frustrating. It can be very, very frustrating. But I believe you can do this. So I hope that you won't give up, and if there are questions that I can answer for you, I hope that you'll ask them. And if you haven't already subscribed, please subscribe. Thanks very much for the support.